Hey everyone, welcome to this video where I'm gonna be showing you a simple hands-on example that uses EigenDA. So before we get on to the hands-on example, this particular piece of testnet example is actually a fork of the OP stack that uses EigenDA as the DA layer instead of the Ethereum DA layer. And therefore, just to give you a quick context of what is OP stack, it is the standardized, shared and open source development stack that powers Optimism. So Optimism uses OP stack, which is maintained by the Optimism collective. OP stack is open source, so anyone can actually fork the OP stack and build their own rollup with some add-on changes as they would like, which is what is exactly this particular simple solution that we are going to be discussing. And of course, we are going to be using EigenDA. The DA refers to the data availability. Well, so far in your traditional settlement layer, like if you think about Ethereum, your data availability layer is the Ethereum, right? We index information from the Ethereum, we send information to the Ethereum, etc. But it's extremely expensive. It occupies a lot of space and is also not gas optimized, right? So therefore, the concept of DA layers is coming up, where DA layer in itself can be a separate modular layer. Your Ethereum can be the execution or the consensus layer you can have, which gives you an entire modular stack. Now EigenDA is the data availability store, which is made by Eigen Labs and it's built on top of EigenLayer. So EigenDA is essentially an AVS that is registered with the Eigen protocol. Now let's take a quick look at the architecture of how this simple example works. Now, when you see a rollup, it has a sequencer that is responsible for creating the blocks. Now, in this case, the OP stack rollup sequencer, the OP batcher, is actually responsible for creating batches of the data and sending it to the EigenDA network. Now, here you see the different operators, right? These operators have registered this particular AVS as the one that they would provide the service to. So in this case, what happens in this particular EigenDA network is that once the blobs of data, batches of data is actually published by the batcher to the EigenDA network, there is a EigenDA blob key that is generated and which is sent to Ethereum as call data. So in general, you would actually create blobs, right? So you have blob data. However, in this case, you are going to reduce a lot of data by just generating a key. So you're majorly storing the data on the data availability layer and you're just using the key to find out that particular piece of data. So that's exactly what is happening. There is some modification in terms of having some EigenDA contracts that have been deployed on Ethereum. And the interesting thing about this solution is that this particular solution will work even when the EigenDA network is down. So you have to also build your solution in a way that when your DA network is down, it automatically switches back to the Ethereum call data. So this is the example that we are going to be looking at. Let's jump right into the demo. Before that, I found the documentation on alt layer while I was researching for examples. As a developer, I always want to experience things hands-on, and I found this example, so super amazed at that. So this particular OP EigenDA testnet, as I mentioned, is an OP stack powered L2 that uses EigenDA as its data availability layer. Now the transactions are written to EigenDA instead of the Ethereum call data, as you saw in the architecture diagram, and the resulting blob key is then written to the Ethereum call data. So the cost of the call data becomes negligible, and even when the blob is pretty big. So then the sequencer retrieves the blob keys from the call data and then it retrieves the blob from EigenDA whenever you want to get the data, right? So there is a user guide and stuff that you can also look at, but it's pretty straightforward. If you're a Solidity developer, then it's a piece of cake for you to already start using this rollup. So there is a guide which tells you as to you can basically add this particular network to your wallet. Okay, so I'm going to connect my wallet to MetaMask now. So I'm on this network, which is the OP EigenDA Sepolia testnet. Please remember that this is a testnet, just an example, right? Now they have given all of the different details that you need to add manually to your MetaMask if required, and then you also need to bridge. So you see the next step is bridging. So you get some Sepolia ETH into your, if you don't have Sepolia ETH, then you get it into your Sepolia testnet, and then you need to go to this bridge interface to bridge it to this particular rollup, right? So from your Sepolia, you can bridge this to your OP EigenDA Sepolia testnet. So I've already bridged it, and you can see that's why I have 0.5 in my wallet, 0.499. Okay, so now that we have the network is available, we can directly just take a look by just deploying a simple contract. So I just started a simple workspace on on Remix, and yeah, let's deploy simple storage, so we don't have to give any parameters or anything, right? Okay, now we can just, we need to refresh. Okay, I have this network now. I'm just going to take the simple storage, save it, and then let's just deploy it. Okay, so you can see that this is the OP EigenDA Sepolia testnet. Confirm. Okay, so the transaction was confirmed. I'm gonna copy the transaction ID, and let's go to the block explorer. Super. Okay, so you can see that now you see the transaction details, which is, you get the hash, you have the block. So this is your simple L2, and then you have, from my address which I deployed, new contract was created. So you can see that the contract address is also there and such, and this is the block, and some more details about that related to the block. And then you can see that the gas price is literally like super less on this rollup. Of course, at the moment it is a very straightforward rollup, it's not doing anything much, but you can see that your storage cost can become super less. Even your transaction finality, like it just took 22 seconds for this to kind of go through. Of course, there are no token transfers, there's just this like the contract that was created. So you see internal logs, and yeah, you see the state that by the miner that mined this, and then you can see all other different types of information. So you see that from this you have this much gas, then you initialized, and then there's like the address of the contract and stuff like that. So actually what is happening at the backend is that your data is getting stored on the EigenDA layer, and as a user, like basically you don't even have to worry about what is happening. You can just start using this, and your data automatically is getting stored on EigenDA, right? So you can build more cool stuff like this, and you can of course experiment around with what are the different things that are happening in this space, what are some solutions that you can build, and what are some interesting things where you can have EigenDA. So EigenDA, even as a generic rollup, you can also use EigenDA as your DA layer, and it's just super simple. You need to add the provision, or you can have the users also choose what DA layer they want to go with, right? So that's also quite interesting for them, like whether they want to choose EigenDA and then they pay X amount of cost, whether they want to choose Ethereum, then they have to pay more cost, and things like that. You can build a lot of interesting applications where users can decide to choose what is the DA layer that they want and things like that, right? So a lot of interesting stuff that you can do, and yeah, this is pretty much it that I want to show you as the demo. I'm excited what you folks come up with as ideas on by using different AVSs that are already there offering to make your life much easier. Awesome, thank you so much, and thanks for watching this video.